Okay, so this is do the ratios form a proportion. Remember, all this work is due on Monday, the 17th, before class. So when you go in to do this one, you see that you have 9/18 and 3/16. So can these be simplified to be the same proportion? So let me choose a different color. So 3 can be divided by 3. This can be divided by 3, which will give me 1/2. This can be divided by 9 on the top and the bottom, which would give me 1/2. So you can see here that these are equivalent fractions, so we would say yes. Let's do one more. So we have these two, 4/1 and 12/3. 1 goes into 4 times, and 3 goes into 12 4 times, because 3 times 4 is 12. As you've noticed, these now have the same number because they've been simplified, so we would say yes. Please remember the SMART score you have to reach is 85. So this is for the IXL assignment. Identify proportional relationships by graphing. So you can see that here on the right, and this is what it will look like when you go in to try to do it. So let's read this. While relaxing on her front porch, Evelyn notices a garden snail crawling on the sidewalk. Evelyn is amazed at how slowly the snail moves, so she starts timing it. In 3 minutes, the snail moves only 6 feet. In 4 minutes, it moves only 8 feet. So in this relationship, X represents the amount of time in minutes that Evelyn spends timing the snail, and Y represents the distance in feet that the snail moves. Graph the 2 points for the relationship and the line passing through them. So basically, we're just going to be graphing these 2 points. So we're going to look at minutes first, and it says that in 3 minutes, the snail moves only 6 feet. So I'm going to go to 3 minutes and 6 feet. And then let's go back here, and we have 4 minutes, moves 8 feet. Here's 4 minutes, 8 feet. And then there's my line. And then I say, yes, it's proportional because it goes through 0, and all the dots can be found on the line. Oops, then I have to hit submit. Let's do one more. And, honestly, like I always tell you, just identify the numbers. Here's 3 minutes. We're dealing with minutes and inches. That's what we're comparing. 3 minutes crocheting today, the scarf in a total of 6 inches long. So 3 minutes, 6 inches long. And what's the next one? After 6 minutes, the scarf is a total of 7 inches long. So 6 minutes up to 7. So let's make sure we did that right. We got 3 and 6. We got 6 and 7. Now let's check it out. Is this proportional? Well, this doesn't go through 0. Yes, all the dots are on the line, but remember, it has to go through 0, the origin. So this is a no. We're going to hit submit. Great. Now let's move on to the next assignment. Okay, so this one is find the COP, the constant of proportionality, from a table. So find the constant of proportionality from a table. So here we are. Remember, if you need to look at an example, make sure to click this and expand this, and it'll kind of walk you through how to do it. This is really similar to what we were doing in all of our table making during our note sessions in class. So Dale wants to save up some money to buy a new smartphone, so he babysits on the weekends. Is there a proportional relation between the time Dale spends babysitting, that's in hours, that's your X, and the amount of money he earns babysitting in dollars, which is your Y, right? Now remember, it's asking for dollars per hour. That's Y over X. Why'd the cop pull you over? Y. Y on top. So 5 over 1. So how many dollars per hour? $5 per hour. This next one. You got the Y over 1. 1 swing per 5 days. This is a little different, right? So we got to be careful when we're reading. So how many swings per day? So I would say we're looking at here, looking at the table. See, if you look at the next line, we got 1 over 5, but that's 1 swing for 5 days. We need to know how many swings per just 1 day. Well, we can try to see what the constant proportionality is, the COP. What's the common one that keeps repeating? So 2 over 5, that can be simplified to 1/5. 3 over 15, 1/5. So this is going to be 1 over 5. Let's see. Ooh, oh, we had to put it as a decimal. So if you had 1/5 on the calculator, you would have to put it in as a decimal. So make sure that you put it in as a decimal. Here, how many muffins per cup of flour? Make sure you're always paying attention to what's being compared. So that's 4 muffins for 1 cup of flour. Here, 2 over 2. Well, 1 inch per book. Because when you simplify that, it should just be 1. Here's 4 over 1. How many bells per wagon load? So 4. And here's 10 over 5. And so as you can see, it's going to be pretty easy for some of you, but make sure your number gets to 85. Okay, this one is your 4th IXL assignment, and it is identify proportional relationships between graphs and equations. So this is how we do this one. Remember, SMART score needs to be 85. If you need to look at an example, you can expand this to see if you need further clarification. So let's see what it says. Select the graph that shows a proportional relationship between X and Y. Well, looking at your notes, what are the 2 things you need to make sure you know on a graph? Number 1, has to go through the origin. Number 2, has to include all the dots. So check it out. Goes through the origin, goes through the origin. This one doesn't have dots, but it is a straight line, and this is a straight line. So we're going to check both of them. This one, straight line through the origin, curvy line through the origin. Oh my gosh, I don't think so. Not proportional. And then here, what's this? Select the equations that shows a proportional relationship between X and Y, and they're giving us an algebraic rule. Well, it has to have a constant. And remember, the coefficient is also the COP, the constant, and we got to have a variable of some sort. So I would say this one. And let's roll the dice. Let's see what happens if we don't select this other one. Ooh, see? Now you see these two have an X, a variable with the coefficient equal to Y, the algebraic rule. So where both of these apply. Now let's look back here through the origin. Yeah, through the origin, straight line, straight line. So we can select both of them. What? Nelly, what if they give us a square? Well, this one, yes. And I'm going to say, yeah. Let's see what it tells us. Ooh, not correct. So now you can see why this wouldn't be correct. And it's really important that if you make errors, that you see why you made the error. And of course here, I can just explain to you that when it's squared, it's no longer an algebraic rule, right? The rule has to look like this, y equals 3x. If they didn't have the square, then it would work. Of course, that's what that tells you down here on the very last paragraph. Straight line through the origin, straight line through the origin, both. And then here, see, so you would have learned from this mistake knowing that you cannot do this. And oh, let's see, y equals x. Remember, you can have an imaginary 1 in front of that x. See? Through the origin, not through the origin. Perfect example of not through the origin. And then here, of course, these both qualify. Here, both qualify. And I mean, you can quickly, oh, well, what happens when they give us this? Well, this is an algebraic rule. Can this one be 2? I'm guessing yes. We haven't gone into these details, but let's see. No. So that's how you can see, and it doesn't drop your score by too much. But no, like I said, the algebraic rule can only be the coefficient and the variable. Can't have any of these extra things like squares or +1 or -1. It can only be the coefficient and the variable. Alrighty, so now let's move on to the very last task. So very last IXL task. Remember, you have 5 IXL tasks that you have to do. And the last one is identify proportional relationships from tables. So this is just focusing on the tables. So here we are. Select a table that show a proportional relationship between X and Y. Well, if you need help, expand this so that you can see or get reminded what a proportional relationship looks like, right? We have to have a constant. So 4 divided by 4, is that 1? Yes. 5 divided by 5, is that 1? Yes. 1 divided by 2, so that would be 2 over 1. 4 divided by 2 simplified would be 2 over 1. So we can say that both of these would. Here, okay, 4 over 1, right? 8 over 2, if I simplify that, that should be 4 over 1. So that one would be okay. This one, 6 over 1, yes. But 9 divided by 2 is not 6 over 1. The constant is not the same between these two. So that's a no. And then here you would see 4 divided by 2. When you simplify that, that'll be 2. This one, it's not that. When you simplify 6 over 6, it's not 2. So that would not qualify. And then here would be 5 over 1. And then 2 goes into 10 5 times. But 3 goes into 15. 5 times. So this one would be okay. So what happens if you do it incorrectly? What does it look like? Let's see. So if you were to select one incorrectly, you can see that here it explains that these are not proportional, and it can tell you here when you do the math, the y over x, this is 1 and this is 5 over 4, and you can see they're not the repeating number, the constant. However, this one was, when you do it, 1 over 5, 2 over 10, you can see there's a constant here. And then you can move on. Don't forget that you have to hit 85 for all of these 5 assignments. So let's bring this back up so you can see what those 5 are. Do the ratios from a proportion, number 1, and then identify proportional relationships. Find the COP from a table. Identify proportional relationships between graphs and equations, and identify proportional relationships from tables. Feel free to watch this over and over if you forget how to do the problems. Thank you. And remember, this is due Monday before class.